Hey guys, this is my completed mod 100 counter which I've made by using several of these ICs. Now these are the 7447 decoders, that is the BCD to 7 seg decoders. These are two 7 segment digits, and then there are the two counter ICs that I made use of, 74HC191. These were the ones available. These are the binary counters. You can also get BCD counters which are available. Then there is the NAND gates, NAND gate ICs, that is 7400. Then these are actually used to convert the binary to BCD. Then I've also used several other ICs over here. So one thing to note is that this entire combination over here of these three ICs is actually the same over here as well. These are actually representing the two digits. So these work hand in hand, and these are the two NAND gates which are actually used to make the Arduino programming input. Then there is a small timing circuit, which is the internal clock. I made it using triple timer IC. Then there is another potentiometer which is used to dim the brightness. There is a button which is used to either give it an Arduino input or the internal clock. Then there is the other triple timer IC which is used to debounce that switch. Then there is a voltage regulator which I made use of. Then there's just a 7405 voltage regulator which is used to regulate 12 volts. Then there is the Arduino inputs. Then there is a small switch which is used to actually reset the counter. Let us power this on. So yeah, as you can see, initially it might take some random values because obviously it can start with any state, so you can just reset it using that little switch. Then let's just see how the brightness is controlled, or how the brightness can be controlled. So right now I'm trying to vary this brightness. Yeah, as you can see, the brightness can be varied. So let's just give it an Arduino input. So I've just connected the Arduino input over here, and as you can see now, I'll toggle the switch, and I've given the Arduino sequence as 5, 10, 30 and 10. Actually 5, 30 and 10. That is actually the sequence: 5, 30, 10, and then repeat. And I'll just dim the brightness a little bit and just switch off the lights. So that's what it's basically doing. I can actually program this to count any value or any sequence I want. So yeah, as you can see there, once I press the button, there are a few glitches which I can actually avoid. So that is because of the interference of the Arduino's clock with the internal clock. Let's just turn on the lights. Now I'll just increase the brightness, and I guess it's time to remove the power supply and the Arduino inputs. Let me show you the back of this circuit. So this is what it looks like. It took me 3 days to solder, and there are a lot of connections and resistors. That's it. And a few capacitors. So like, share and subscribe. Thanks for watching.